Hi guys, so we're going to pick up with operations with radicals. In a previous video we did simplifying radicals. Now we're actually going to do the operations with radicals. So let's look at this first one right here. So you can see we got the square root of 54 plus the square root of 6. Now what you have to understand is in order to add these together, you have to have the same number inside both radicals. So the radicals have to be exactly the same power. Like right now, these are a square root, and they have to have the same number in order to add them together. So think about something like if you have x plus x squared, you can't add those together because they're not like terms. But if you had x squared plus x squared, you would say that is 2x squared. So it's kind of something similar to that when you're working with the operations with radicals. So when we get to a problem like number one, what we want to do is simplify every single radical first. So let's simplify as much as possible. Well, square root of 54, we know we can say is 9 times 6. Remember, simplifying, we're trying to take out the perfect square within, like break up 54 into multiplication where one of the numbers is a perfect square. And that becomes the square root of 9 times 6. And the square root of 6, there's nothing we can do with that. So this is looking good so far because now we can get those to be the same, which means that we'll be able to add them together. Well, of course, the square root of 9 is 3, so this is 3 square roots of 6 plus, now we know there's a 1 there, so it's plus 1 square root of 6. So again, think of something like this, 3x plus x, what is that equal to? That's 4x. So if you have 3 square roots of 6 plus 1 square root of 6, you have 4 square roots of 6. And that is how we do number one. So let's look at number two. You can see we have a number in front right here. We got the 4, it's a multiplication. And we know what that means. We did it with simplifying the radicals. So again, the goal is to try to get these two to be the same if possible. And we're only going to know that if we simplify them all the way. So the square root of 12 we can say is 4 times 3 plus, and the square root of 27 we can say is 9 times 3. So we'll be able to take these numbers out because they're perfect squares. Now remember, there's already a multiplication here, so it's going to be 4 times, and the square root of 4 is 2, square roots of 3, plus square root of 9 is 3 square roots of 3, which then of course 4 times 2 you get 8 square roots of 3 plus 3 square roots of 3. And I missed my equal signs here. And then what does that become? Well, 8 square roots of 3 plus 3 square roots of 3 is going to give us 11 square roots of 3. And that is finished. So let's look at 3 terms here. We're going to add 3 radicals. So we're doing the same thing. We're going to just simplify all the radicals that we can, see if we can get them to be the same. They may or may not be able to get to be the same. It doesn't matter. We're just going to simplify them as much as possible. So 2 square roots of 6, nothing we can do there. Square root of 6, nothing we can do there. Plus 3, and we can say square root of 24 is 4 times 6, because that is a perfect square, and we'll be able to take that out. So then I'm going to go ahead and I'm just going to rewrite everything. I know a lot of students don't like to do that. They don't want to rewrite because they think it's just kind of wasting time. But I think it's important to keep everything organized. So square root of 4 is 2, so that comes out. And then again, let me put my equal signs here. So this is 2 square roots of 6 minus the square root of 6 plus 6 square roots of 6. All right. And now you can see that all of these are the same. Now we know the number in front here is a 1. So think about it this way. If you had 2x minus x plus 6x, what would that equal? So 2 minus 1 is 1, plus 6 would be 7x. So going along the same lines, this would be 7 square roots of 6. Sometimes it's easier just to see it like that with a variable than using the radicals. All right, let's move along here. So now we're going to multiply. So if we're going to multiply these, you want to multiply the numbers on the outside together. And then we're going to multiply the numbers inside the radicals. That's the way it works. So we have 3 times 1, which is just going to be 3. And then we have the square root of 10 times the square root of 20, which is the square root of 200. Now we see if we can simplify this radical at all, because we're not finished yet, if we can simplify it. And we can, because this is 3 times the square root of 100 times 2, because 100 is a perfect square. It's the largest perfect square that we can break this up into. And then, of course, we'll say this is 3 times 10 square roots of 2, which gives us the final answer of 30 square roots of 2. All right, moving along. So let's look at number 5. This time, we're going to have to do distributive property. So we're going to have to multiply square root of 10 times this, and then the square root of 10 times this, using the same property or principles that we did over here with this problem. So if I'm going to multiply square root of 10 times 3 square roots of 2, it would be the 1, which we know there's a 1 here. No, it's not written. So 1 times 3 would be 3, and the square root of 10 times the square root of 2 is the square root of 20. And then we're going to multiply the square root of 10 times 4. Well, I only have the 1 square root here, and then I only have the number out here in front, so that is just going to be 4 square roots of 10. You can't multiply a number on the outside of a radical with a number inside. This is not equal to the square root of 40. You can't do that. So now we're back to some of the early problems that we did. Can we get these two to be the same? We may or may not, but we're going to simplify as much as possible. So this would be 3 times the square root of 4 times 5 plus, and there's nothing we can do with the square root of 10. So we already know that these are not going to be the same, which is okay. We're just going to simplify as much as possible. So this would be 3 times 2 square roots of 5 plus 4 square roots of 10. Of course, I keep neglecting my equal signs. So this would become 6 square roots of 5 plus 4 square roots of 10. And there's nothing else we can do with that. So this is the simplified answer. There's nothing more we can do with that. All right, so let's look at the last one here, the one that's more difficult. So now we're going to have to multiply a binomial times a binomial here. So distributive property, we're going to multiply the 4 times the negative 4. Let's do that first. So that's going to give us negative 16. Then we're going to multiply 4 times negative 2 square roots of 5. Now, if you have to do it off to the side, you can. So it's 4 times negative 2 square roots of 5. And then that is going to be negative 8 square roots of 5. So we're going to put that here. Some students can just go ahead and do it right away, or some need to do it off on the side. Now we're going to multiply 5 square roots of 5 times negative 4. Again, you can either do it off on the side. 5 times, put that in parentheses, negative 4. So that's going to be negative 20 square roots of 5. So minus 20 square roots of 5. And then we have the last 5 square roots of 5 times negative 2 square roots of 5. So with this one, if you multiply a radical times itself, you just get what's inside. So minus 2 square roots of 5. So this 5 times negative 2 is negative 10. And then the square root of 5 times the square root of 5, which I understand is the square root of 25. But of course, that square root of 25 is 5. So that's what I was saying. If you multiply a radical by itself, you just get what's inside. So then we can just say that this is negative 50, excuse me, that didn't come out right. So minus 50. So now what can we do? These are definitely like terms. And then these are actually like terms, so we can go ahead and add those. So I'll do the negative 16 minus 50 first. That's going to give me negative 66. So that's done. And then negative 8 square roots of 5 minus 20 square roots of 5 is minus 28 square roots of 5. And that is it. So hopefully this will help you with the different problems when you are actually perform any operations on radicals. I try to give you a good variety, so hopefully it will help. And I will definitely see you on the next video.